In my last video, I discussed the northwest corridor rule method for finding the initial basic feasible solution. Today, I am going to discuss another method, that is matrix minima method. And the last one I have already mentioned, that VAM method, Vogel's approximation method, to find out the initial basic feasible solution. This is the first step for finding the optimum solution for any transportation problem. Again, I am repeating, today I am going to discuss the matrix minima method. Matrix minima method. This is the transportation problem. What is transportation problem, that I have already described in my previous video. If you have any doubt, please check that. Here the factories, suppose the production are being done in 4 factories A, B, C, D. That means this is the location of the factory. These are the location of the factories. Say the production is being done at Jamshedpur, Kolkata, Allahabad, and any other place in Nepal, like that. And EFG are the marketplace or warehouses where the production units are to be shifted for sale. Now, how will proceed? And these are the cost. These are the transportation cost per unit. Again, I am repeating. Suppose this means if the production unit of factory A is being shifted to warehouse or sales point F, then per unit transportation cost is rupees 8. In this way, all transportation costs are mentioned in this matrix. Again, I am repeating, say 8. What is this? This means if the production unit for factory D is being shifted to warehouse or godown, say G, then per unit transportation cost is rupees 8. Now, with the help of matrix minima method, I have to find out the initial basic solution. How you will do it? See, I will do it. I will start. You check the least cost. You check the least cost from the transportation table. Transportation cost 10, 8, 9, 4, all this one. Which is the least one? That is the matrix minima, means which is the least cost in the matrix. In this case, 2 is the least cost. Now, you have to first allocate this least cost cell. In this cell, you have to first allocate the quantity which you have to ship from factories to warehouses. How will you allocate this? So out of 20 and 26, you select the minimum one. That means in this case, for 20 and 26, the minimum one is 20. That's why we will write or we will allocate 20 units. That means you shift from B production unit to F warehouse or marketplace 20 units. Then how much will be left for production units? 0, because 20 units have been shifted to warehouse F, and this is the remaining demand. 20 means 6 units is still to be shifted. In this way, you have to start. Now, when you have shifted the entire amount for production units B, then it is understood that you cannot shift to this place because the entire or all production units have already been shifted. That's why I have noted a dash mark. That means mistakenly you should not put any amount to these cells because the total units you have taken production units. After this, what will you do? Next, you select the immediate next minimum cost, but you will not consider this because you cannot allocate to this cells. So out of 10, 8, 9, 6, all this, which is the minimum cost cell, this is the minimum cost cell, minimum transportation cost cell. That means you have to allocate the production units to this cell. How much you will allocate? From 30 and 49, you select the minimum one, and for these two, 30 and 39, means 30 and 49, the minimum one is 30. That's why you will allocate 30. If instead of 49, if it is 28, then how much you will allocate here? 30 and 28, you will allocate 20. In this way, you will put the minimum of these two units. That means from factory C, you have to shift to warehouse G 30 units. Okay. Then what will be the remaining units required to be sold? In this case, the production unit remains for factory C is 0 because entire 30 units have already been allocated here, and requirement, the balance requirement is 30, this means 19. Still you have to shift 19 units as the entire units have been allocated to these cells. That's why it cannot shift to these cells. There is no scope to shift any unit to these cells because the entire available units have been shifted. Okay. Now, how we proceed? Next, then again select the minimum cost from the remaining cost. 8, 6, 7. Out of this, the minimum cost is 6. That's why this is the place where you have to allocate. How will you allocate? 6 and 35. Requirement is 6 because the balance requirement is 6 and the production rate for this factory is 35. Out of these two, you have to select the minimum one. Which is the minimum one? 6 is the minimum one. That's why you will allocate 6. And what is the required units for this warehouse? 0 because the entire 6 you have allocated. And what is the production unit that remains to factories D? That is 29. 35 minus 6, 6 has already been shifted. That's why the remaining units available to factory D is 29. As it is 0, that means you cannot allocate here because the entire amount required for warehouse F have already been allocated. 20 and 6, total 26 requirement for this warehouse spaces have been fulfilled. That's why it is not possible to shift any units to this cell. That's why I have blocked it. Now how will proceed next? Again select the minimum cost out of the remaining cost units. 7, 8, 9 and 10. Which is the minimum? Minimum is 7. That's why we have to allocate here because 7 is the minimum. That's why we have to allocate here. What amount we will put here? 25 and 29. Out of this, the minimum one you can allocate. Say in this case 25. You cannot allocate 26 here because it is not possible. Requirement is 25. It is not possible in that way. So you have to select the minimum. If it is say 35, then what amount you will write here? Then if it is 35, then you have to put here 29 because 29 in that case will be minimum in this way. That means you have to select the minimum one. That means the requirement left is 0 and the units still available for factory D is 4 because out of 29 units 25 you have shifted here. That means 0 means you cannot put any amount to these cells because the requirement have already been fulfilled. Now the remaining cells to allocate is 9 and 8. Again select the minimum one out of 9 and 8. So minimum cost is 8. That's why you have to allocate here. How much you will allocate? 4 and 19. 4 and 19, the minimum is 4. That's why 4 will be allocated here, and the difference is 15 units requirement still available, and in this case the production units will be 0 remaining, because if you add 6 plus 4, 10 and 20, 35, this is the available units, it is fulfilled. Now the last one is cell is this. You have to allocate here. The balance you can allocate 15. The requirement is the production units and requirement unit is 15. That's why this is 15. This is also 0 and this is also 0. In this way, you can find out the initial basic feasible solution through matrix minima method. Just again I am repeating few steps. This is a transportation problem. You have to solve this. That is, you have to find out the minimum cost for this transportation problem. But how you will find out the minimum cost? That I will discuss later on in second step is required. That is that is MODI method. And this is the first step to find out the initial basic feasible solution. At the beginning, you always check that the availability and requirements are same. In this case, factory A is producing 15 units, factory B is producing 20 units, factory C is producing 30 units, factory D is producing 35 units, and the total is 100 units. This is the supply, or you can say available of the products, and the requirements are noted. Yeah, 20 of any query you can mention in the comments box. Thank you. So what will be the transportation cost for this initial basic feasible solution? Basic feasible solution means what is this? Where is the solution? Solution means, basic feasible solution means from production unit A, you have to shift 15 units to the warehouse G. From production unit B, you have to shift 20 units to warehouse F in this way. From production unit C, you have to shift 30 units to warehouse G. And from production unit D, you have to ship 25 units to warehouse E, and from production unit D, you have to shift 6 units to warehouse F and 4 units to warehouse G. This is the initial basic feasible solution. You can check it. If you add all these units, then you will get the total available units. 6 plus 4 plus 25 is 35, is satisfied. Similarly, if you check 30 units, 30 is also available. This is same. And if you check it, that is 20 units which have been shifted, it is also available. And row wise you can check 15 units, this is 15. If you check vertically, then you can check the total shifted units will be equal to the requirements. 15 plus 30 plus 4 is 49. 20 plus 6 is 26, which is the requirement, and 25 is the requirement. In this way, you can prepare the initial basic feasible solution, from where you will start to optimize by applying MODI method, modified distribution method, and step by step I will discuss that total cost of this transportation problem of this initial allocation will be changed, and finally you will reach to the basic feasible solution, which will be the least cost or the lowest cost. At this initial stage, what will be the transportation cost? The transportation cost will be is equal to 15 into 9, 15 into 9, because for shifting one unit from this source to this warehouses, per unit cost is 9, and you are shifting 15 units. That's why the total cost for this 15 into 9 rupees, plus per unit shifting cost is rupees 2, and 20 units are being shifted. That's why 20 into 2 plus 30 into 4 plus 30 into 4 in this way, plus 25 into 7, 25 into 7 plus 6 into 6, 6 into 6, per unit 6, the 6 units are being shifted. That's why plus 4 into 8, and you will get the total cost for transportation will be in this way. $15 into 9, 20 into 2, that is 40, 30 into 4, that is 120, and 25 into 7, and 36, and 32, and the total cost will be calculator you got insufficient light, that is 15 into 9. Okay, the total cost will be 15 into 9. Due to insufficient light, it is not being reflected here. The total cost will be 538. 538. Thank you. Thank you. This is all about the matrix minima method. In my next video, you please check that I will discuss the VAM method. Thank you.